Okay, guys, let's start chapter 4. This chapter is going to be about the periodic table. We're going to talk about today is the history of the periodic table. We're going to talk about why it's called the periodic table. We're going to talk about who came up with it, the scientists that came up and formed our modern periodic table. We're going to talk about a lot of the different family names on the periodic table, why it's arranged the way that it is.
Why are the names that they are?
And yeah, we'll talk about that today. So, good question, Brandon Cahoon. So let's get started. Okay. Hopefully, if you're watching the video, you have out your guided notes. We're on chapter 4 guided notes. Be filling it out as we go through these slides. And another thing you're going to need today is a periodic table, so make sure you have that out. Okay, let's start with the history of the periodic table. It says, throughout the 17 and 1800s, scientists began to notice how elements' chemical properties repeated every eighth element. So the chemical properties, how it behaved chemically, repeated every eighth element. So let's talk about that for a second. What they would notice, for example, like if they had lithium, if you see lithium on your periodic table, let's count over how many elements over, let's count 8 elements over and see which element we get to. So 1, 2, 3, 4, 5, 6, 7, and 8. What element is that? So yeah, if we start with lithium, count over 8, we come back to sodium. And this is what the scientists were figuring out, was that lithium behaved very similar to sodium. Okay, well, let's start somewhere else and count 8 over. Okay, let's go to carbon. Count over 8. So nitrogen would be 1, 2, 3, 4, 5, 6, 7, 8. What element is it? So right, 8 over, wasn't it Si? Silicon?
Yeah.
And so they noticed that these two elements would behave almost exactly like each other chemically. You guys should know why. Why do they behave similar? Same, good job. Good job. Same number of valence electrons. How many valence electrons does lithium have? 1. How many does sodium have? 1. So all of these guys have 1. What about carbon? 4 valence electrons. What about silicon? 4. And so that's what they noticed when you organize the table in a way that every 8th element was under the one above it. They would have similar chemical properties. Okay.
What about like calcium?
Yeah, same thing. Calcium behaves very similar to who? Oh, I see what you're saying.
Yeah.
Okay, but guess what? When you go over to SC number 21, that's in the D orbital block, so it goes down in energy level. So the only ones you count are the S block and the P block because they're the only ones up.
I got you.
Yeah, good question though. Okay, this repeating pattern was called periodic. This repeating pattern was called periodic since it repeats in a specific manner. So something that repeats itself in a predictable and specific manner, we say that is periodic. What are some things in the world that we know that repeat in a specific manner? Days of the week. Don't they repeat in a specific manner? Okay. What about days of the year? Isn't 1 year always 365 days? What else is repeating? What else is repeating? School is repeating, right? It's periodic. What else?
Yeah.
Not really. But that's not a predictable. It's not predictable. What are some predictable events, guys? Holidays. What else? Sunrise, sunset, the length of the day. What about this? We don't live by the coast, so we're not too familiar with tides, but are tides periodic? Sure they are. What about the phases of the moon?
The star lines.
Phases of the moon, are they periodic?
Yeah.
Yes. And so anything that repeats in a predictable and specific manner we say is periodic. That is why, guys, that's why it's called a periodic table. Every eighth element, the chemical properties repeat themselves. That's why it's called the periodic table. I would know that. Okay, by the late 1800s, scientists had arranged the elements by increasing atomic number and put them into columns according to similar chemical properties. So if they arrange them by atomic number, what does that mean? It's the number of what?
Protons.
Protons, yeah. So they arranged them by the number of protons that they had in their nucleus, and they put them into columns. Well, if you put them into columns, what does that do? It's similar what? Number of valence electrons, right? That's what they were doing.
Wait, so we put valence electrons in that?
No, columns. Okay. Okay, so that's kind of how they started coming up. They discover an element, they put it according to its atomic number, and into columns according to similar chemical properties. There's this thing in chemistry called the periodic law. Let me give you a second to write this down, and then we'll talk about it. Okay, so let's go through this definition together. Periodic law is the periodic repetition of chemical and physical properties of elements when they are arranged by increasing atomic number. So we've kind of talked about it on the previous slide, but why do the chemical and physical properties repeat themselves every eighth element? All of these guys have how many valence electrons? 1 VE. How many do these guys have? 2 valence. Okay, we kind of skip over the transition metals here, this D block of elements. And how many valence do these guys have? 3, 4, 5, 6, 7. And how many here? 8. Except for helium, which has 2 valence, 2 VE. And that's what causes them to have similar chemical properties. They all have the same number of valence electrons. Okay? Okay, so that is periodic law. It's repeating every eighth element. Okay. Scientist. Guys? Here's the scientist who contributed to the periodic table. There's a spot in your guided notes that asks you for 4 scientists who contributed. I don't want you to write all the bullets down. I just want you to write the names and the years. So everything that I'm underlining now, I would put in your guided notes. Okay. John Newlands, and then put the year. Okay, so there's John Newlands, there's Lothar Meyer, there's Dmitri Mendeleev, and Henry Moseley. I want you to put a star next to number 3. That would be this guy. Dmitri Mendeleev is given the most credit for creating our modern day periodic table. Okay. He's a Russian chemist. Yeah, let's make that note. He was from Russia. He's a Russian chemist. But why is he given the most credit? Let's talk about it right now.
Because he was from Russia.
Okay? And the answer is this bullet right here. Dmitri Mendeleev predicted the existence of properties of undiscovered elements. So not all the elements had been discovered when he was putting together his periodic table. But what he did that was so genius was he left a blank. If he knew that there was an element there that was going to have properties to the ones above and below it, he would leave a blank. Well, guess what happened as they were discovered? They fit in perfectly with blanks that he had left because he knew that there was an element that was going to be discovered that would fit there. And all of his predictions came true. And so he's given most credit for creating our modern day periodic table, Dmitri Mendeleev. That's the only one I will require you to remember. So just remember number 3 there. Okay, the modern periodic table contains boxes. And here's what most periodic tables will contain. Here's the information that they will give you. It gives you the element's name. Okay, this periodic table gives you the element's name right there. All spelled out. They give you the element symbol. This is usually a 1 or 2 letter symbol. For oxygen, it's just 1, just an O. They give you atomic number, which is the number of protons in the nucleus. The atomic number for this one is right here, number 8 for oxygen. And it will give you the atomic mass. The atomic mass is in this periodic table is given at the bottom. We learned in chapter 1, atomic mass is the average. It's a weighted average of all the isotopes of that element. So usually there's a decimal place. So it's the weighted average of all the isotopes. And then there's a lot of differences in periodic tables. Some give you information, more information than that, and some don't. Well, this one says the states of matter. Has a little balloon for oxygen. How come? Because it's a gas at room temperature. Okay. So you're going to find that there's a lot of different periodic tables out there, but most of them contain this information. Okay, let's talk about how the periodic table is organized. There's columns of elements that are called groups or families. I want you to make this note in your guided notes. Columns, guys, go up and down. A column goes up and down. And on the periodic table, those columns are either called groups. So if you look right here on this giant periodic table, it says group number 1. Group number 1 is hydrogen all the way down to francium, Fr. Group number 2 is beryllium all the way down to Ra, and so forth. How many groups are there, guys? 18 groups, all the way over to the noble gases. Or we call them families. Right, Will?
Yeah.
Yeah.
What's my name?
Okay, rows of elements are called periods or series. Rows, I want you to make this note. Rows go left and right. Okay, so it goes left and right. Rows of elements are either called periods or series. They're called periods because they repeat every 8th element. They repeat in predictable manner in terms of their chemical properties. Okay, so rows are called periods or series. Okay, elements in groups 1 and 2 and 13 through 18 possess a wide variety of chemical and physical properties and are called the representative elements. Guys, the representative elements would be groups 1 and 2. This is 1 and 2. And 13 through 18 are these guys over here. Okay. So the s orbital block and the p orbital block, these guys are called the representative elements. Yeah, they possess a wide variety of chemical and physical properties. Okay, before I move to the next slide, what do we call this on the periodic table? Going up and down. Column. What are 2 other names we could say? Families or? Groups. Yeah, groups or families. What if it goes this way? Left and right. This is a row. What are 2 other names we could call it? A period or a series. Okay? We got to get that down. Okay, elements in groups 3 through 12 are known as the transition metals. So if you look here, here's group 3 and here's 12. So what they're talking about is the d orbital block. They're known as the transition metals. Okay, groups 3 through 12 are the transition metals. All right. Elements are classified as either a metal, a nonmetal, or metalloids. So every element on the periodic table can either be a metal, a nonmetal, or a metalloid. Let's talk about the metals first. Metals are elements that are generally they're shiny, when smooth and cleaned up, they're very shiny. They're solid at room temperature. And they're good conductors of heat and electricity. What does it mean to be a good conductor? Does that mean heat can go through it easily or not so easily? Yeah, very easily. If you've ever welded before, you get done putting a weld. Should you grab that piece of metal with your hand? No, because it's very hot. Heat moves through metal very easily, and so does electricity. That's why our electrical wires are made of metals. Copper is a metal. Okay, let's talk about the first family on the periodic table. The first family is called the alkali metals. Say it, alkali metals. Alkali metals. Are all the elements in group 1 except for hydrogen. Is hydrogen a metal, guys? No. Why is it in group 1 then if it's not an alkali metal?
The same valence electron.
Yeah, it's got one valence electron. Very good. Okay, so just remember all of the elements in group 1. So we're talking about lithium down to francium. They're called who? The alkali metals. That's their family name. You're going to be tested on that. And guys, they're very reactive. I'll show you at the end of class. We'll put some sodium in water and watch how fast it will react. Okay, why do you think they're so reactive? They have 1. How many do they want? 8. So they're just going to get rid of that 1 electron to anyone that will take it. And so they're very reactive. Okay, let's go to the second family on the periodic table. Here it is. They're called the alkaline earth metals. The alkaline earth metals. Say it. Alkaline earth metals. And they're all of the elements in group number 2. They're also very reactive. They're trying to get rid of those 2 valence electrons. Guys, when I was going through school and I learned chemistry for the first time, it was hard for me to differentiate between alkali and alkaline earth metals. For some reason, I keep mixing them up. So I came up with something. If it helps you, great. If it doesn't, I'm sorry, think of something else. Okay, but if we look at our solar system, and this is the sun. Do you guys know the planets in our solar system from the sun out? In 6th grade, you learned this. There was a mnemonic. My very energetic mother just served us nachos. Did you learn that?
Yeah.
Your 6th grade teacher say that?
Well, it was Pluto too back then.
Or did you miss that day at school?
No, I was there.
You were there? Okay, so my stands for what planet?
We lost the
Guys, oh wait. My stands for what planet? Mercury. Very stands for what planet? Venus is right here. Energetic stands for what? Earth. Okay, so this one's Earth. We're the 3rd planet from the sun. So here's how I remembered the alkaline earth metals. How many planets are before Earth? 2. What group are the alkaline earth metals? 2. They're in group 2. So if that helps you remember that the alkaline earth metals are group 2, great. If it doesn't, you'll have to find some way to remember that.
You just add on 2 more words.
Sage.
What would the orbitals, what group would they go in?
They don't really have a group number. Good question.
Yeah, you just add on 2 more words. The N and the E. Alkaline. See, 2 more words.
Brandon's got his own way. That's good.
Sweet. I nailed that.
If that helps you guys, good. If not, if you don't know what Brandon's talking about, just forget he said that. Okay. Let's talk about another group of elements. Okay, another name to remember here. The transition elements. Okay, the transition elements are groups 3 through 12. So we're talking about this chunk right here. But they're divided into the transition metals. So here's the transition metals that I just circled on the periodic table. And the inner transition metals. Here's the inner transition metals down here. If you remember, there's an asterisk right here after 56. Barium is 56. The asterisk tells you that 57 is down here. Why do they pull those guys out? Guys? Because these 2 rows should really be put here and here. How come they pull them out and put them down below? Why do you think they do that? Look at how big this periodic table is. If you put these two rows in right there, how long would this thing be? It'd be super long. Would I be able to put a periodic table on the wall? No. So that's the only reason. To save space, they pull them out and put them down there. But what are these last two rows called? Inner. Here's why they're called inner, because they really should fit inside right there.
So if they're different though, how come they're different orbitals? Like if they're not different.
Well, they are different. They are different.
But you just said
They are. Yeah, they are. Okay. The two sets of inner transition metals are called the lanthanide series. The lanthanide series is called that because this element La is called lanthanum. So they call it the lanthanide series. And then this element AC is actinum. And so they call it the actinide series. A series, remember, is a row that goes left and right. So you got the lanthanide series and you got the actinide series. Okay, now let's talk about the nonmetals. Nonmetals are elements that are generally a gas, or they're very brittle. If they are solid at room temperature, they're very brittle, and they're dull looking. They're poor conductors of heat and electricity. What's another name for a poor conductor? Isn't it an insulator? You guys remember that? Okay, an insulator. So these guys are good insulators because they don't allow heat or electricity to pass through them very easily. Okay, another family that we've got to know. Group 17 is right here. These guys have a family name. What is it? Group 17 is composed of highly reactive elements called the halogens. So that's another test question. Group 17, what are they called?
Hooligans.
Not the hooligans, the halogens. Okay? And one last family on the periodic table is group 18. Well, here's group 18 over here, and we've already learned them. What are they called? Yeah, these guys are called the noble gases. But it says they're extremely unreactive. Why do you guys think they're so unreactive? They already have their 8 valence electrons. They don't want to give their electrons to anyone, and they don't want to take any electrons from anybody else. Because that would mess up the octet rule, right? They already have their 8. They're stable. So that's why they're called the noble gases. They're the nobility of the periodic table. These guys are the kings. Do they want to interact with the common folk over here? No. They're always going to be by themselves because they already have 8 valence electrons. Okay, there's another group on the periodic table that we've got to know, and they're called the metalloids. Some chemistry textbooks will write it as semimetals. So I want you, in your notes, to kind of put this in the margin. Semimetals and metalloids mean the same thing. Okay? So the metalloids have chemical and physical properties of both the metals and nonmetals. So they behave kind of like a metal, but kind of like a nonmetal. And so if they're in between, we call them a metalloid. An example of a metalloid is silicon, and germanium. We'll talk about those later. Here's probably the most important thing today that I want to talk about. Put a little star by this bullet. The most important thing of today. The bold staircase on most periodic tables. This one right here doesn't have it, but yours does. I'm going to draw it in. Starts right here at boron and kind of just makes a staircase. All the way down. Okay, that staircase is very important. Here's why. It separates the metals from the nonmetals. And elements close to the bold line are considered the metalloids. So, let's talk about this. If it's up here above the staircase, what are these guys called? They're the nonmetals. That means everything below the staircase are what? These are the metals.
Should we write that?
Yes, I'd write that. Above the staircase are the nonmetals. Below the staircase are the metals.
But now hydrogen is.
Good. Yeah. There is always one exception, isn't there? Always has to be that exception. Hydrogen's in. Is it a metal, guys? No. Why is it over here then? This has one valence electron. That's the only reason. It's really a non-metal. So you just got to remember that hydrogen really should be with the non-metals, but it has one valence electron, so we put it in group 1. Okay. That will be tested. Here's how I will test it. I will say calcium. Is it a metal or a non-metal? And you guys are going to say what? It's a metal. I'll say fluorine. Metal or non-metal? It's a non-metal. Now there's one more. The metalloids. We're just going to say, and keep it easy and kind of make a generalization here, that if it's touching the staircase, it's a metalloid. Or a semi-metal. Okay, so if it's touching the staircase, it's a semi-metal. So if I asked you about silicon, metal, non-metal, or semi-metal, what are you going to say? It's a semi-metal. Okay, pretty easy. Now there's a lot of different examples of periodic tables that you'll see online. I just pulled a few out from Google Images. Here's one. Okay. Let's go through kind of a quick quiz and see if you guys got everything, because we're done with this video almost. What do we call this first family on the periodic table? What's their name? Alkali metals. Except for who? Hydrogen, because it's just got one valence electron. It's really a non-metal. What do we call family group number 2? Alkaline earth metals. What do we call this chunk of elements? Transition metals. What do we call this chunk of elements? The inner transition metals. There's 2 more that have names. What do we call this family? Halogens. What do we call this family? Noble gases. What do we call it if it's above the staircase? All of these guys. Non-metals. What do we call it if it's below the staircase? Metals. What do we call it if it's touching the staircase? Metalloids. Okay. Very good. Okay, so we're going to make a periodic table that looks like this. If you're watching the video, have a periodic table out, and we're going to color it in this pattern. Okay, I want to make you aware of a couple of places that you might have questions about. First of all, hydrogen. How come it's not colored purple like the rest of these alkali metals? Because it's not a metal. So when you color this, make sure hydrogen is not included, and you've got to have a key down here. They're called the alkali metals. Group 2, who are they called? Alkaline earth metals. Please color them a different color and make a key at the bottom. Alkaline earth metals. Okay, notice these 2 asterisks are colored the same as these. How come?
That's what that means.
That's what it means. It means these elements are really down here. What are they called again? Inner transition metals. Color them a different color. And you'll notice they colored the transition metals green. Now I want to skip to this family. What was it called again? Halogens. Color them a different color. This family, what are they called? Noble gases. Color them a separate color. And then look up here specifically. These are the metalloids. Okay, that are colored in blue here. But you're going to say, well, aluminum, it's touching the staircase. How come it's not blue? Well, aluminum is definitely a metal. Okay, it has more characteristics of a metal, so it's not a metalloid. I will not ask you about specifics here. We're just going to make a generalization saying if it's touching it, it's a metalloid. But for this periodic table, it does get pretty specific, and it tells you exactly which ones are the metalloids. So make a key for them. So how many different colors do we need? There's 7 different colors. Okay? So get your periodic table and color it like this. I'm going to hit pause until we're done, and then I'll have a few questions for you. Okay, just to finish up, let's make sure that we've got your periodic table and it looks like this. Okay, be careful around the staircase, just to color these ones blue. Carbon, nitrogen, oxygen, these guys are all just white, and so is aluminum all the way down and through this region. And hydrogen is white. Okay? I hope that you colored it like this and that you've made a key. The key is most important because we're learning the different classes of elements. I also want you to make this note on your periodic table. Okay, here's the staircase. I want you to make a note. Everything above the staircase is a what, guys? It's a non-metal. Okay, everything below it is a what? Is a metal. Okay, and if it's touching it, it's called a metalloid. Or a semi-metal. Here's what the test will be like. Okay, I'm going to give you, like, I don't know, I might give you copper and say, what class of elements is copper in? And you're going to say what? It's a transition metal. Okay, I might give you uranium. What class of element is uranium in? The inner transition metal. What about magnesium? The alkaline earth metal. Okay, what about rubidium? It's an alkaline metal. What about silicon? Metalloid. What about bromine? Halogen. And what if I said xenon? Noble gas. Okay, so that's going to be what your test is going to be like. These are the different element classes, the different classes of elements. So hopefully that helps kind of organize these elements into different classes, and hopefully that helped